Hello everyone, myself Professor Rakesh Patil from the Department of Civil Engineering, KLS VDIT Hyderabad. I welcome you to the lecture series on groundwater and hydraulics. The subject code is 17CV 742, 7th semester, model number 4, and today we are going to discuss about lecture number 25. Before going to the proceed with today's class, I would just like to brush up the things which we have discussed in the previous class. In previous class, we have discussed Thiem's equation for unconfined and confined aquifers, how the drawdown values increases and how the yield capacity of the aquifers changes. That we have discussed in the previous class. With that background, we are going to start in today's class, and today we are going to start with a new module, that is fourth module. The module name is groundwater exploration, and first topic is groundwater exploration only. In this module, we are going to discuss about identifying the suitable aquifers and identifying the subsurface construction with respect to the presence of the aquifers. That's all present. That's all are there in the fourth module. In that first module, first topic is groundwater exploration. So, coming to the today's topic, groundwater exploration can be divided into two major groups involving geohydraulic and geophysical method. The former method involves the actual drilling of bore well in the area. Geohydrology method are more time consuming and therefore neither convenient to use nor economically sound due to the involvement of drilling cost. On other hand, geophysical method of aquifer exploration are faster and very much successful all over the world these days. The following information can be derived from the exploration using geophysical method: depth of aquifers and thickness of the aquifer. Then second one is declination of aquifer boundary of a very large groundwater basin. Third one is quantity of a groundwater and the spread of the pollution zones. So these are the applications we can say for the geophysical method, and most of the civil engineers admit this geophysical method for exploration of rock stratas, exploration of water, and to know the ground strata like soil, depth of the soil, and different layers. We use this geophysical exploration only. Geophysical exploration is the scientific measurement of a physical property of the earth crust for investigation of minimum deposit or geophysical structure, geological structure. Based on these indication, it's possible to declinate the subsurface zones of fractures, fissures, faults and lineaments. Analyzing of seismic velocity, a basic understanding of the characteristic seismic velocity for a variety of geological materials is necessary. This velocity helps to identify the nature of aluminum or bedrock in the coarse alluvial terrain. Seismic velocity increases markedly from unsaturated to saturated zones. So let's start with some introduction part. Groundwater is an invisible natural resource. It is available in different proportions in various rock type and at the various depths. On the surface layer of the earth, the historical past, when there is no visible flow of water along the river, people used to dig small pits in the river alluvia, wait and collect the groundwater coming through seepage and use it for the drinking purpose and for meeting the domestic meeting the domestic needs. Similarly to the people of mountainous region, natural springs provides the resources of water supply. Springs are the outcome of a seepage from any groundwater system in a hilly terrain or a limestone region. More than 60% of a global population thrive by using only groundwater resources. The groundwater which was exist at the shallow depth in the open wells has gone deep due to the over-exploration. Exploring these water resources becomes a challenging task to geoscientists. Renewable resources, groundwater is renewable resources. Groundwater gets replenished after every rainfall. This is called rainfall recharge. The level of water seen in the open wells denotes the uppermost surface of the zones of saturation of the porous media. This is called water table. After every recharge, the water table rises, denoting the porous media has saturated with more water. When we pump out water, the water level goes down. Continuous pumping of water beyond the recharge will make the wells go dry and force to deepen the well. The search of groundwater got increased due to the non-availability of sources and due to the declining water tables. And this all we have discussed in the previous module, that is third module, where the each and every borewells drawdown values comparing with the different terrains. Heterogeneous distribution is nothing but its groundwater is not uniformly distributed everywhere. The occurrence of a groundwater varies from formation to formation. In typical crystalline hard rock terrain, the quantitative occurrence of groundwater depends on the weathered and fracture zone. The occurrence of a groundwater in a sedimentary terrain will more promising. Groundwater prospecting is a very tough provoking scientific exercise in the most of the places. This is a need to understand, this is the need to understand the method of groundwater exploration, as it is a practical discussion making approaches. This module highlights some of the general methods of groundwater exploration. Groundwater exploration is a typical task of hydrogeologist or engineer. Identifying the location of its availability is a challenging task. Exploration of a groundwater requires a basic understanding of its position in a subsurface geological setup. Groundwater exploration is attempted through either by direct or indirect method. Test drilling is the direct approaches to find out the resources. This is an expensive affair. Every individual cannot go for the test drilling. During the last century, more and more techniques have been developed to explore the groundwater. They are classified into surface and subsurface method. We will discuss first thing, that is surface method. The surface methods are easy to operate and implement. These requires minimum facility like topo sheets, maps, reports, some field measurements and interpretation of data in the laboratories. The surface method of a groundwater exploration includes esoteric method, geomorphological method, geological and structural method, soil and microbiological method, remote sensing techniques, surface geological geophysical method. Subsurface method. The subsurface method of a groundwater exploration includes both test drilling and borewell geophysical logging techniques. When compared to the surface methods, the subsurface methods are very expensive. These are done for government level projects where large scale investments are carried out to ascertains the result of a surface survey. Geomorphological methods. Surface drainage is subjected replica of topography. It is controlled by the basement rock. Mostly groundwater flow coincides with surface drainage. The streams and water course may also be controlled by some underlying surface structures. Junctions of streams at the down slopes are promising zones for groundwater. Landforms originate due to several geological processes. Study of landforms. Landforms are likely to indicators to show the relative permeable strata, the location of modern alluvial terraces and floodplains, stratified valley, fill deposits, glacial outwash plains, glacial deltas, cames, moraines, complexes, escarpments, alluvial fans and beach ridges are good location for groundwater occurrence. Topography and drainages. Physiographic method analyzes the surface topographic and drainages, the location of confluence and junctions of surface streams at downstreams points of small watershed are good locations for groundwater for confluences. Hydraulic gradient of groundwater system will always follow the topographic gradient and slopes. If it's high, due to more stream, runoff will be more. Geological method. The geological investigation begins with the collections, analyzing and hydrological interpretations of existing topographic map, aerial photograph, geological map and logs and other permanent records. This should be supplemented when possible by a geological field recognizing by the elevation of availability of hydrologic data on stream flow and springs, well yields, groundwater recharge, discharge and levels and water quantities. Next is structural methods. Contact points between permeable water bearing strata overlying relative impermeable strata using along all the sides of valley that cuts across the interference between different stratas are suitable location for the groundwater. Then some groundwater explorations. Water is the basic need for any life to exist in the world. Prehistoric man was leading nomadic life on the banks of rivers with natural calamities such as floods, earthquakes, etc. It was distributed and uprooted from his downlink place with advanced civilization. The use of water increased by leap are bound first for drinking needs, then for supplementing agriculture, irrigation, municipal requirements, and later for industrial growth. Naturally, when the surface water is short supply, one has to depend partially or wholly on the groundwater. Groundwater is more desirable than surface water for at least 6 following reasons. It is commonly free of pathological organisms and need no elaboration purification for domestic and industrial use. Temperature is nearly constant, which is great advantage if the water is used for heat exchange. Turbidity and color are generally negligible. Chemical composition is generally constant. Groundwater storage is always greater than surface water storage, so that groundwater supplies are not seriously affected by short duration drought. Biological contamination in groundwater is seldom noticed. Hydrogeological studies that says it represents the physical reality, its consequences, distribution and determination of hydrological parameters like permeability are especially steep in the groundwater modeling process. In groundwater studies, three distinguished phases may be considered. First one, definition of the hydrological system, simulation of proposed activity, evaluation of side effects. The first phase in groundwater study is the exploration phase, including collecting and interpreting the existing data, reports, field visits, preliminary assessments, topographical and hydrological maps, aerial photographs and satellite images, borewell logs and water quality data, accessible literature geological maps. In second phase, field investigation will be prepared based on the some surveys, inventory of existing well, geophysical survey, test drilling, pumping test and other investigation like net thickness of the basin aquifers. In third phase, additional data will be required like inventory for existing well, geophysical survey, pumping test and other investigation. And foremost very important is geophysical survey will result estimate of thickness of the various subsurface layers. Also information can be obtained regarding the aquifer material, anisotropy and the degree of fracturing. However, the additional investigation like well drilling, logging will be required for the final assessment. The most common methods are geoelectrical, geomagnetic, seismic, geophysical, borewell logging. Electromagnetic methods, the resulting field may reveal the presence of the area of high conductivity. The penetration depth of electric method measurements depends in function of resistivity of the subsoil, the distance between transmitter and receiver and the operating frequencies. In geophysical borewell logging, due to the circulation fluids, the high drilling speed employed in modern drilling techniques, the quantity of soil and rock samples is poor. Using geophysical borewell logging records of the intersected strata of the strata can be obtained. The records can be useful interpreted in terms of subsurface lithology, moisture content and groundwater quality. A logging unit consists of a hoist, recorded and various electrodes of sensors which are lowered in the boreholes. In seismic method, the seismic method elastic waves are generated by a source of energy. These waves are reflected and refracted at the boundary planes between different soil and or a rock layer. And the travelling times of the waves are recorded by sets of geophones. which are located at increasing distance from the impact point. This method is not often used in the groundwater prospecting due to the large capital investment and high running cost. So that's all from today's class. We'll have another session with a different topic. Thank you very much. We'll see you in the next class. Thank you.